Now, how can do it, this type of problem? Our motto determine acceleration of each block. So how can do? Okay. So first of all, make free body diagram of both block. Okay. Here 2 kg and here 3 kg. 3 kg, that is 2 kg. Here 20 Newton, here 30 Newton. Clear or not? We have taken N1, we have taken N2, and this force also apply N1. Okay. I know that if you make the free body diagram of that block, 2 kg mass downward, we have taken G is equal to 10, so that is 20 Newton downward. Surface apply force normal N1, clear, like that one. Second one, look here, N2, this surface apply N2 force upward direction, and 2 kg mass also apply in 3 kg mass in N1. Why? Because Newton's third law. If this one apply 3 kg apply on 2 kg is N1, so N 2 kg also apply on 3 kg block is N1. Clear or not? According to Newton's third law. Clear or not? So first of all, make it. After that, what about N1? If you any ask, what about N1? 20 Newton. And what about N2? N2 basically N1 plus 30 Newton, or N1 is 20, so this one is 50 Newton. Clear or not? Very simple. Now, look here. This one is a smooth surface and this one is a rough surface. Static friction coefficient is given 0.1 and dynamic frictional coefficient is given 0.09. Clear? So how can do it? Clear or not? After that, now look, let us consider if both blocks are moving together. First we have as here, let we assume let both block moving together. Moving together with how much acceleration? A. With A acceleration. Okay. We have assumed. Okay. So how can do it? If suppose that is 3 kg block, this one is 3 kg block and this is 2 kg block. If you apply force on 3 kg block, how much force? 5.5 Newton. Then moving like that one. But this one is also moving. Why? We are force apply on that block, not that block. It means this one is also moving. Why moving? I don't know. No any external force apply anyone. Okay. Only this one connect with connection between these two. So it is possible, or you can say that if you apply here force, if this one is going on like that one, 2 kg also move, 2 kg mass also move in this direction. It means some force apply here, that force called frictional force. Okay, so frictional force help to this block also move. Clear or not? So 2 kg block also move. In which direction? If this one is going on positive x direction, this one, so this one is also moving on this direction. Why? Because of due to frictional force in between. Frictional force in which direction? Applied force. Clear or not? So Fr help to 2 kg. So because I have assumed both are moving like that one, it means Fr help to this block is moving. So Fr is written as 2 into A, equation number 1. Now second one, 3K. What about 3 kg block? If no one oppose, if that force direction 5.5 Newton, this surface are smooth, ground surface are smooth. Now look upward. If what about 3 kg block moving in this direction, but frictional force also due to, if Newton third law, if you assume this block moving in this direction, so Fr helps to 2 kg block moving that direction. Okay, but if we are apply 3 kg block, that is 3 kg block in how much Newton? 5.5 Newton force in 3 kg block. In which direction? Positive x direction. So in that time this surface is smooth, and that force, that surface, that 2 kg block also apply force on 3 kg block in opposite direction. Okay, in opposite Newton third law. So Fr like that one. Okay, so you can say that 5.5 minus Fr, this will equal to 3 into A. If both are adding, then we got A, this will equal to 1.1 meter per second square. Okay, now what about static friction? Limiting friction, that is Fs max. This one is μs into N1. What about μs? 0.1. And what about N1? 20. So that is 2 Newton. What about Fk? Mu k into N1, that is 0.09 into 20. We got 1.8 Newton. Clear or not? Very simple. Now look, this block moving or not decided which one? Limiting friction. Here, check here. What about Fr? Fr is, we put A this equal to 1, that is we got 2.2 Newton. That is 2.2 Newton. Now look, Fr is greater than limiting friction. Fr is greater than, here, Fr is greater than limiting friction. It means both blocks are slide. Okay, this A1 is slide. It means relative motion is possible. So you can say that is relative motion. Motion between two block. Okay, because of this Fr is greater than limiting friction. Okay, requirement 2.2, but this one is given 2 Newton. Okay, means you can say that, suppose that requirement here 2.2 Newton, but this surface frictional force provide only 2 Newton. So this block is, so this one is not, it is not sufficient for both are moving same direction, or you can say both are moving same oscillation. Clear or not? That's why both oscillations are different. Both oscillations are different. Clear? This one is moving. Okay. If limiting friction is greater than Fr, requirement is suppose that 5, but this one is given 10. Static friction given, limiting static friction suppose that given 10, then both are moving same direction. Always no relating motion between these two. But you can say that here limiting static Fr is greater than limiting friction. Okay, so both are moving, both are relative motion between these two. If relative motion between these two, then both are moving same direction with different acceleration. Okay, with different acceleration. Clear or not? So how can do it? First of all, so next free body diagram, that is 2 kg block. During motion, frictional force Fk. Okay, well here N1, here 20 Newton. So Fk, suppose that this one moving with acceleration A1. So 2 into A1. What about Fk? Fk is 1.8. So what about A1? A1 is 0.9 meter per second square. Clear or not? It's very simple. Now we have focused on that block, 3 kg block. Make here 3 kg. Apply here 5.5 Newton. During motion, both are slide. So kinetic friction, oppose motion, Fk. Suppose that this one is moving with A2 acceleration. So it is written as 5.5 minus Fk. This will be equal to 3 into A2. So what about A2? A2 is written as 5.5 minus Fk. What about Fk? That is 1.8 divided by 3. That is 1.27 meter per second square. Okay, clear or not? 1.27 meter per second square. Clear or not? Both block are moving with a different acceleration but same direction. With same direction. Okay? Why? Because of frictional force, requirement friction, static frictional force. This one is greater than limiting frictional force. Okay? That's why make it.